Hey everyone, welcome to yet another check-in session for our Kubestronaut series. Um, very happy to see you all here. Let me just check the chat to see who we have. So we have a few with us. We'll just slowly get started and go through a few things today. So as usual, we're going to go through the check-in session. We'll go through the deck and see where we are and where we're supposed to be and where we are today. And then today, I thought we will do some kind of hands-on session. So we'll pick one of the topics for the newly updated CKA curriculum, and then we'll go through that. I thought we'll pick autoscalers for today, and maybe in the next few sessions, we'll pick some of the other new topics. So I do see a few folks saying hi in the chat. So we have Pradeep Kumar, Swarna Vadatta, Devinder Saab, Nitin. We have Enrico Becker from Germany. We have Kwam. We have Minu Chauhan. So welcome to this session. So without further ado, let's just get started. Let me share my screen. That one. All right, here we go. So first of all, as always, I want to call out some of those who have recently completed their graduations. So starting with JC, who recently completed his CKA exam. So congratulations to JC. We have a new Kubestronaut in the orbit, Hamid Hirsi, who works as a platform engineer at Avanade. So congratulations, Hamid, on completing all of your 5 Kubernetes certifications and becoming a Kubestronaut. We have Francis Makoha, who's earned the CKA. So congratulations to Francis on earning CKA. He works as a DevOps lead at IO. We have Saurish Day, who works as an automation developer at Ericsson, who's completed the CKAD certifications. So congratulations to Saurish. We have Mahmoud, who's completed the CKS. So that's a tough one. Great job, Mahmoud, and congratulations. We have Francis Makoha again. Sorry, that's a duplicate. We have Bijoy Abraham Matthews, who's completed the CKA. Congratulations, Bijoy, on your certification. We have Muhammad Usman, who's also become a Kubestronaut. So congratulations to Muhammad in becoming the Kubestronaut. And we have Preetu Sharma, who's recently completed his CKAD with a score of 91 of 100. That's awesome. Congratulations to Preetu. And we have Vivek Raghupati, who's also become a Kubestronaut recently. So congratulations to Vivek on this achievement. Cool. So just a couple of reminders. In a few weeks from now, we'll be in London sponsoring the KubeCon. So if you happen to be in London, do register to KubeCon and come by our booth. We're going to be there with a lot of fun things, some swags, and books and other resources, study resources. So, and if you're in India, remember that we have the KubeCon happening in August in Hyderabad, and the submission for talks are due by 23rd of March. So that's another 10 days from now. So do submit your talks. This is a very good opportunity for you to work on your delivery skills, to connect with the community, to connect with others, and share your knowledge. So I would highly recommend submitting your talk. Cool. So here we are with the Kubestronaut cohort path 1. So we are towards the end of March. So by now, a lot of you are supposed to have the CKAs completed. So definitely drive towards that towards the end. Just get those exams booked and make sure you follow through. Once that's done, in April, the goal will be to hit CKAD, which if you do the CKA, is going to be very, very easy. It won't take you more than a month to prepare for the CKAD. And then, of course, from there on, KCNA would just take you another month. The CKS might take you a couple of months extra. So that's a lot of new topics going in there. And then we have in September, you could easily do the KCSA and be ready to be a Kubestronaut by the end of the year. So just picking up a couple of questions that are being asked. So Suarnava asks, do we have any videos on how to book the CKA exam? I already had purchased it earlier. So if you purchase the exam on the CNCF website, it's as easy as logging into your account and selecting the exam and proceeding to select a time slot that you want to prepare for the exam, and then sit on that. So that's a good idea. Maybe something I could do is record a video for it, just in case you need any additional assistance there. So yeah, thank you for the suggestion. So the path 1, we thought were better for those who can go at it at a bit more fast-paced, who has some experience working with Linux systems, right? But for those of you who are just starting out, we decided that we're going to start with the KCNA. So KCNA is a non-hands-on exam. It's a multiple choice exam, so that's easier to get started. By now, those who have started in the cohort 1 are supposed to have completed the KCNA and then started preparing for CKAD. And then we'll do CKA, CKS, and KCSA. Cool. So for path 1, you all should be at about 90 to 95% completion of the course. We should have the last couple of weeks, you should be going through storage, networking, design, and install. And then the next couple of weeks are for troubleshooting and mock exams. So really, there almost. So just really push through and make sure to get it done. And those who are on path 2, by now you should have completed the certification, completed the course, and must be attempting the exams. So all right, one thing that we announced last time is the Notes app. So go to notes.kodekloud.com, and you should be able to access notes for all of our applications. Sorry, all of our courses. So it's not all there yet, but we are continuing to add more and more courses, but at least the Kubernetes courses should be there by now. So if you go here and select CKA, you should be able to get all the notes from the CKA course. And today, what we're going to do is focus on some of the new content that we have added for the auto-scaling section. And this is what we will go through today. Cool. And so just talking about the exam updates. So as you all probably know already, the CKA exams were updated on February 18th. So close to a month ago. And there are a bunch of areas that got updated. So the sections around upgrading a Kubernetes cluster using kubeadm or etcd backup and restore seems to have been removed. And we have new concepts like Helm and Customize, and understanding extensions, right? CNI, CSI, CRI, understanding CRDs, installing and configuring operators. So these seem to be the new topics that have been added. So this kind of hints a shift from like moving away from having to manage the entire cluster yourself, doing all the underlying kind of the dirty work. Instead, how do you operate a cluster, or how do you manage a cluster that's already provisioned, right? So a lot of kind of the underlying operations are kind of being automated. So whenever you work with managed Kubernetes clusters on, let's say, Google Cloud, like GKE or AKS on AWS, Azure, in Azure Cloud Services, we are not ultimately like relying on doing the kind of the dirty work underneath. So kind of hints a shift away from the more of the manual operations. And then here we have one of the things in the workloads and scheduling section is the configuring auto scaling section. And then we have configuring pod admission and scheduling. So today we're going to look at this particular section here called configure workload auto scaling. So let me just share my screen. All right, so this is a new section that's added to the course. What we will do is, today I thought we will do a study session where we'll pick one of these topics and we'll just go through and we'll also kind of do the labs and get some hands-on experience. So auto-scaling in Kubernetes, there are primarily few areas. One is the horizontal pod autoscaler. So that's the HPA, the vertical pod autoscaling, or the VPA. And then you have the cluster proportional autoscaler, the CPA. And then we have the Kubernetes event-driven autoscaling, or KEDA. Today, we'll just focus on the first two, the super simple ones. And then probably in the future sessions, we'll look at CPA and KEDA. When it comes to the CKA exam, I think the more relevant areas are the horizontal pod autoscaler and the vertical pod autoscaler. So these are the topics that are added to our CKA course, and that should be sufficient, along with the labs and mock exams, that should be sufficient for you to handle and tackle the questions in the exam. Now, if you're interested in learning more about these topics, then we have a course that's specifically designed for Kubernetes autoscaling by Michael Forrester. So I would highly recommend you to take a look at that. So starting with autoscaling, let's first look at what it means by scaling, right? So let's go back. Let's forget about Kubernetes and containers for a second. And if you go back to the plain old servers and apps that are hosted on them, what happens when load increases and when we run out of existing resources on the server, right? So when we need to scale up. And in the past, what we did was we would take down the server, the entire server, and then scale it, and then scale up the resources, and then power up the server back on. So there was a downtime. This is like, we're talking about really old days. So that's what's called as vertical scaling. So you're basically taking down the server, adding more CPU memory resources to it, and then bringing it back. So you're basically kind of increasing the size of of a single server, and that's called as vertical scaling. And then after the whole cloud computing era started, we no longer had to worry about servers, right? Because before the cloud computing era, you only had a limited number of servers that you had access to. So you had to work with what you had. So you had to take it down and add more resources and bring it back up. But after the cloud computing era started, you could now provision as many servers as you want, however you want, and you could take them down however you want. So that brought in new possibilities, and you no longer needed to take down servers and increase capacity to it. You could now add additional nodes to it. And so that's adding additional nodes is to an existing cluster, and thus increasing capacity is called as horizontal scaling. So we also spoke about, we've been speaking about orchestration. So now we come to this whole cloud native and containers world, right? So with cloud native and containers world and Kubernetes, now we have servers that are part of a cluster, and then you have pods that are hosted on those servers. So now what we could do is we could horizontally scale by adding more pods to our cluster, right? Adding more pods to our application. So that's scaling workloads. But then there's also, you also want to scale the underlying infrastructure. So that's when you add more pods to your existing cluster, and your cluster is no longer able to support or does not have that much of capacity left, so you want to add more nodes to the cluster, and so you have you want to scale your cluster infrastructure, and that's called scaling cluster infra. So there's two concepts here. There's scaling the underlying cluster infrastructure, and then there's scaling workloads, right? Now let's look at how both horizontal and vertical fits into this. So what does it mean by horizontally scaling cluster infrastructure, right? So that's as easy as saying you add more servers to your infra, you add more nodes to your cluster. What would it mean by saying vertically scaling a cluster? That would mean you basically take down your server, you add more resources to it, and then you bring it back up. So that's called vertical scaling. Now, when it comes to scaling workloads, what does it mean by horizontal scaling? So when it comes to workloads, horizontal scaling is adding more pods to your deployment, your replica set, whatever you want to call it, or running more instances of your application. That's scaling your workload. And what would it mean by scaling, vertically scaling a workload? So this is adding more resources to an existing workload. That's called vertically scaling your workload. So let's say you provision a pod with certain CPU and memory, and you know that it's going to hit that threshold, and when it hits the memory threshold, it's going to be taken down. When it hits the CPU threshold, it's going to be there's going to be a limit that to the CPU that it can use. And vertically scaling a pod would mean you increase the resources available to that pod, right? So so those are the two types of things. There's the horizontal scaling and vertical scaling for both cluster and scaling workloads. And there are two ways that you can do. There's the manual way. So manual way, and then there's the automated way. So when it comes to manual, how do you manually add more servers to your node? You provision additional servers, and then you run the kubeadmin join command to make those new servers part of your cluster. There's no vertical scaling. There's no really options for vertical. I mean, vertical scaling is simple, right? It's exactly what we mentioned. You take down the server, you add more resources to it, and you put it back. So that is kind of the worst option out of all of these options that are available, right? Because you definitely don't want to take down the server and add resources to it. That's just so old approach, right? That's such a traditional approach. So not even going to look at that. With scaling workloads, we have the horizontal scale. So that's if you're already familiar with Kubernetes, you're basically using a kubectl scale command and running that against the deployment, and you're scaling your pods that way. And then when it comes to vertical scaling, you're editing the configurations or the resources available to an existing pod to increase the resources that are assigned to it. And then you save that, and then either it creates a new pod, and then you kind of get the vertical scaling functionality. So this is how you would manually do it. And then you have what are the automated options available? So for automated cluster scaling, you have the cluster autoscaler that basically provisions and adds more resources to the cluster as needed and removes nodes from the cluster when it's not needed, right? When it comes to scaling workloads, we have the horizontal pod autoscaler that scales the number of pods in a system, and then we have the vertical pod autoscaler that scales the resources assigned to a pod in a system. So this is what our area of focus is going to be. That's in our courses, but today we're going to look at just the workload scheduling area, so the horizontal pod autoscaler and the vertical pod autoscaler. So let's start with the horizontal pod autoscaler. So let's first understand how you would scale a workload the manual way, right? So here we have a deployment. It's called my app, has some labels called my app. It has one replica. It uses the Nginx image, and it has some resources assigned to it. There's the CPU requests and CPU limits, which are set to 250 cores, millicores, and 500 millicores. And then you have the horizontal scaling. So what we would do is we would first look at the top pod command and understand what are its CPU and memory requirements. So as you can see, the CPU requests are 250M, and the limit is CPU is 500. And if you look at the pod here, and if I'm doing this manual way, what I would do is I would sit on a system and keep running the kubectl top pod command and keep monitoring this pod, the resource usage on this pod. And then I would see that it's hitting for 450, which is very close to the limits that are set on that pod. That means it can't go beyond that. So that's probably an indication that there are more users coming in, and this pod is like really taking a hit. Sorry, is the screen share working? Sorry, I just thought I lost the screen share there for a minute. Okay. So yeah, so just continuing. So as I see that there is the requests that are increasing on a pod, and remember that this is we're only able to do this because we have the metric server installed, right? So if you want to run the kubectl top command and see the results, then you want to make sure that you have the metric server installed. And as I see that there is a pod that's hitting the limits, you want to run the kubectl scale deployment command with the app and specify the number of replicas to 3, and then it adds another 2 replicas to that deployment. So now we've gone from 1 to 3 replicas in total, and then that's how I would scale it manually. So, and that's where the horizontal pod autoscaler comes. So with the horizontal pod autoscaler, we have what it does is it observes the metrics. It adds or removes pods as required to make sure that it balances it across the cluster. And there are ways to track multiple different metrics. So coming back to how horizontal pod autoscaler works, what we can do is use the kubectl autoscale command, targeting that particular deployment. And we say CPU percent is 50, and the minimum number of replicas is 1, and maximum is 10. So what it would then do is it would then constantly monitor the metric server and compare the metrics of that deployment, of the pods in the deployment, to the requests and limits that are set. And it would look at the replicas, and every time it crosses the 50% threshold for the CPU limits, it would start increasing. So if you do the kubectl get HPA command, you'd see the horizontal pod autoscaler that is created for that particular deployment, and you'll be able to see that where the numbers are. So the targets are 30% and 50%. The minimum number of pods is 1, maximum is 10, and the current number of replicas is 1. And if you want to delete the HPA, you run the kubectl delete HPA command. So that was the kind of the imperative way to create an HPA. So the declarative way is to create a pod definition or a HPA definition file. The API version is autoscaling/v2. There's the horizontal pod autoscaler, and then you have the target ref. So that refers to the target, which is the deployment, my app in our case. And then we have the minimum and maximum number of replicas that we've specified. And then we have the metrics that we're going to be specifying, which is called, in this case, it's the CPU and the utilization and the average utilization. So note that HPA comes built in with Kubernetes since version 1.23. So there's nothing you have to do. If you're on a version later than 1.23, just HPA is just there. You just need to configure it. So let's look at metrics, right? What are the metrics that it can refer to? So by default, it refers to, you have the metrics server. So once you have the metrics server installed, you can run the kubectl top command and query it, and HPA can interact with the metrics server. But apart from the metrics server, you can have a custom metrics adapter that can then, which is like a custom code that can then ping or poll your workloads internally. So you can have a workload. Let's say you want to figure out a way to scale depending on the number of users. And let's say the number of users are stored in a workload, like such as a deployment. So say you want to query your internal database or an application and figure out the number of users on it, and depending on that you want to scale. So then you would use a custom metrics adapter for that purpose. But then that's just internal. You can also have external adapters. So let's say monitoring platforms like Datadog and Dynatrace, they'll have these adapters that you can then plug into your HPA. So Datadog and Dynatrace, these platforms already monitor your entire system. They have a lot of information about your environment, so you can query those information and then configure HPA to scale up or down, based on those details. Again, those are covered in our Kubernetes Autoscaling course, so do check that out. Cool. So let's move on to one of the labs. All right, so let me start the first lab. By the way, if you guys have any questions, feel free to drop it in the chat. So link for the practice test based on the new updates. So the new updates are throughout the course. So if you go to the course and if you look at this, everything that's highlighted as 2025 updates, these are the new updates for this exam. And there's practice tests are all over. So you should be able to find the course, the learning material, as well as a practice test right after that. Similarly, if you go here, towards the end, you have this whole section about Helm and Customize, and you're going to be able to see the practice tests as part of that. We also have some lightning labs that we call it, which are which are going to test your speed, and then at the end we have the mock exams as well. All right. By the way, all of these have been updated. So our mock exams and our ultimate mock exams, the labs, all of them have been updated to match the latest changes in the exam curriculum. And we are continuously making more updates to it as we receive feedback from everyone. So do share your feedback as and when you encounter something different. Right, so we're just going to go through this real quick. So we have the manual HPA. So this is how you manually scale a Kubernetes deployment. So it's not a HPA, it's a manual way to scale a Kubernetes deployment. So let's just get started. So there is a deployment file, a manifest file that's provided, and it is available in root deployment. So let's take a look at that file first. So we have the deployment definition file. It's called deployment Flask web app. It has 2 replicas. It has the labels and selectors set to Flask app, and it uses the Flask web app, and it's on running on container port 80. And then we have a service that is also used to expose this application. All right, so the goal here is to create this deployment. So I'm just going to do kubectl apply deployment.yaml. So I'm already in root, so I don't need that, but yeah, just to be consistent with the question, I'm going to create the deployment. So I've now created the deployment. just going to do kubectl deploy, and we see that we have the Flask web app currently deployed, and it is now ready. So you always look at this to know if it's actually ready or not. And that is also a tip for the exam. Whenever you create something, just make sure it's in a ready state. Another way to do that is also do a kubectl describe deploy, and you just do a deploy. Because we only have one deployment, I can just do a describe deploy. I don't need to give the name. Just another tip, just save you 2 seconds there. So here we have the image that's used, the labels, and then we can see that here's the deployment. Let's scale the deployment to from 0 to 2, because that's the default behavior. So it first creates a deployment and then looks at what are the number of replicas defined for it, and then scales it up to that number of replicas. So super simple. Let's do check. All right. So that's successful. We're moving on to the next one. So what is the primary purpose of the kubectl scale command? Is it to create a new namespace? No. To update the image of a running container? Of course not. To delete a Kubernetes object? No. And to adjust the number of replicas in a deployment or replica set? Yep, that's the right one. Can the kubectl scale command be used to scale down a stateful set in Kubernetes? So do you have to use a scale down flag? I don't think so. It's not there. So you always use scale, and up or down doesn't matter, right? So it's a declarative system. You just say scale to 2, it will scale to 2, scale to 100, it will scale to 100, as long as the resources are available. It works for it says no, it only works with deployments replicas. That's wrong. It works for everything. Stateful sets cannot be scaled down. It can scale both deployments and stateful sets. So that's the right answer. So let's manually scale the deployment to have 3 replicas, and observe the changes with the kubectl get deployment and kubectl get pods command. To view the application, click on the ingress button at the top of the terminal. So here we have an ingress button. So if you click on that, you get to the new page where you have this beautiful green application. Sorry, not so beautiful. And then we also have a Schooner link. So this is basically an open source, a free tool that you can use to monitor your applications. So your cluster. So there is a token that's found here. So go here, copy this token, and put it in here. Yeah, and of course, don't share your token in public, but this is an ephemeral environment. It's going to be deleted as soon as I end this session. So just going to skip that part. But yeah, if you go to the Schooner interface, you're going to be able to see the number of nodes, the number of pods, the kind of the status of those pods, and a bunch of other things. So there's something you can use. So going back to my question, the goal is to now scale your application to 3 replicas. So I'm just going to do kubectl scale deploy, and it's Flask web app, and I'm going to say replicas equals 3. And then I'm going to do a kubectl get deploy, and here I have the Flask web app with just 3 replicas. Awesome. So I'm just going to continue. And the last question is, if you scale a deployment using kubectl scale to a higher number of replicas, but the cluster has insufficient resources to accommodate all new replicas, what will happen? Right. So this is basically asking if the deployment has to provision a number of replicas, a large number of replicas, either when you create the deployment itself or when you scale an existing workload, right? Either way, what would happen when Kubernetes receives a request to deploy more resources than it can handle? So it'll scale the deployment down automatically to fit the available resources. No, it's not going to do that, right? So it's not going to automatically scale it down as in these numbers, right? So the numbers that we have requested, it will always remain, but the number that is ready, that's in question, right? So even if you so it does not scale down automatically. So some replicas will be created up to the limit of available resources, and the deployment will remain in a pending state for the remaining replicas. So that looks more like it. So it's never going to change these numbers, but it's going to change the number of replicas that were requested. So that's what scaling down means, in our reference. But the number of ready instances is what matters, right? And that's so I could just say scale to 100, and this will go up to 100. So let's try that. Right? So it's never going to say I can't do that, right? If I scale to 100, it's going to say scale to 100. It does not scale down automatically. It does not say, hey, you can't scale to 100, so change it to 3. It doesn't do that. It will still say 100, but it's just going to put the others in a not ready state. Let's see what's happening here. So it's scaling up. And I don't know at what point it's going to stop. Okay, it just seems like it keeps on scaling. All right. So yeah, that's the right answer to this. It keeps on going. Let's try to crash. Oh. So we have a 206. Okay, so there is no. Oh, it's deployed 42 now. So there's no metric server on the current node. I think that's why. All right. So let me stop the lab before we crash the KodeKloud labs for everyone. Let's move on to the next part, which is now how do we implement HPA? That's the next question. By the way, just taking a look. Cool. So a couple of questions. Just taking. So when is the next cohort starting? So we have a new cohort starting in April. So that's 15 days from now. So you can. We'll share a link to the waiting list in the links below, description below. So there's a question around, do we have online training rather than recorded sessions? So yeah, we do actually. So if you go to KodeKloud.com, at the top, there is something called for teams. And if you select that, you'll see live instructor-led trainings. So do check that out. Do we have the course for Go templates? So we have a Golang course. Is that what you were referring to? Or is there anything specifically that you're looking for in terms of templates? So if I participate in the Kubestronaut program, do I still have to pay for certifications? Yes, you do. Certifications need to be paid by yourself. All right, so continuing with this. So we have the HPA with imperative commands. That's what we're going to look at in this lab. So we have a deployment that needs to be created. So I'm going to say apply deployment. We're already in root, so I don't need to specify root. So I'm going to do get deploy, and we see that We have 7 replicas for this, okay? And we have a link to Schooner. Just gonna open that. Okay, so we have 2 nodes in the cluster, and we have 21 of 23 pods. There are a couple of pods that are, I guess, having issues. But yeah, most of our pods that are relevant to our exercise, these are the Nginx deployments, have been scheduled. Let's see, workloads. Yeah. So we have 10 of 10 workloads ready, 17 pods ready as requested. Yeah, this is our Nginx deployment, and we have 7 out of 7 pods. Okay. All right, so let's check. Next. So we have a manifest file to create autoscaling for Nginx deployment located at root autoscale. Root autoscale. And the question is, review the manifest file and identify the current replicas and desired replicas. So here we have at the bottom, current replicas 0 and desired replicas 0. So it's option D. That's what I'm going to select. Oops, I accidentally clicked on that. So create an autoscaler for the Nginx deployment with a maximum of 3 replicas and a CPU utilization target of 80. So the CPU utilization target is 80. The max replicas is 3. So it's already set here, whatever we have to do in this case. So let's just create that. We do a gate HPA. And we see that the HPA named Nginx deployment is created. And it has the target set to 80%. Minimum pods is 1, max pods is 3. And let's check the deployment. And as you can see, the deployment has 3. So remember, we had 7 replicas that were defined on the deployment earlier. And now we have reduced it to, with the HPA has automatically reduced it to 3. Right, that's... Next, what is the primary purpose of the horizontal pod autoscaler in Kubernetes? To automate the creation of services, automate the scaling of cluster nodes. So not the creation of services, right? So that's not the right answer. To automate the scaling of cluster nodes. That is also not the right answer, because we know that it doesn't have anything to do with the nodes themselves. It is got to do with the workload, the pods, right? They automate the scaling of pods based on observed CPU utilization or other select metrics to automate the deployment of new applications. So this is the most appropriate. It's used to automate the scaling of pods based on certain metrics. So what component in a Kubernetes cluster is responsible for providing metrics to the HPA? We know that it's the metric server. So what is the current replica count of the Nginx deployment after deploying the autoscaler? So the current replica count is 3. What is the status of the HPA target? So if you do a kubectl get HPA, we see the target is set to unknown and 80%. So what does that mean? Like, what does it mean by unknown? Let's try and ask. Yeah, what does it mean by unknown 80%? Let's see what the AI assistant has to say. it indicates that the HPA is unable to determine the current CPU utilization of the pods. This is often because the deployment does not have any resource requests defined for the CPU. The HPA relies on other resource requests to calculate the current utilization and compare it against the target. Without these values, it cannot determine the current usage. Let's check how accurate that is. Describe, deploy, Nginx. Yep. Think that's what it says. So if you look at, let's do the kubectl describe HPA Nginx deployment. We'll see, what does it say? It says invalid metrics, first error, failed to get CPU resource metrics value, failed to get CPU utilization, missing warning. All right, so it's unable to get those metrics. So the deployment does not have any resource fields defined. The Kubernetes cluster is not using namespaces. The metric server is not available. Let's look at the metric server. Okay, so the metric server is definitely available. So that's not the issue. So as the AI assistant said, the issue is that we haven't specified resources fields in the deployment. I think that's right. Yeah. So if you look at the deployment here, it does not have a resources field defined, and that's why this is set to unknown. So since the HPA is failing due to a resource field missing, in the Nginx deployment, the resource field has been updated in root. So if you look at the deployment file, we now have a resources field here. And the goal is to update the deployment. So we're going to do a kubectl apply deployment -f. Let's see the deployment now. Okay, now we can see the resource requests and limits that are defined here. And let's do a get HPA, describe HPA. I think it's going to take some time. Yep. So as you can see now, it's no longer unknown. It's 0%. Right. So if you do a get HPA, you can see that the now you have it 0% and it's no longer unknown. Okay, what does the event scaling replica set in the Nginx deployment HPA indicate? So I guess it is increasing the number of pods. What is the cause of the failed get resource metric event in the Nginx deployment HPA? So is that, let's take a look at this. So we run the kubectl events HPA command and look at the failed get resources event. It says failed to get CPU utilization, missing request for CPU in container Nginx of pod. So this was the older one, the older warning. This is one way to look at the events for a particular resource and look at additional details. So in this case, it is because of the missing request for CPU in the container pod definition file. Yeah, so that just confirms what we had discussed. All right. So we have 10 more minutes. Let us now. I think it may be good to wind down. So feel free to ask your questions here. But next week we're going to look at, during the next session, we'll look at more in depth in other areas, some of the other concepts. So especially gateway API. I think that's a good one to look at next. So we have Then we have the troubleshooting section, network services. So that's network policies primarily that we have added to the course too. So that could be another session that I'd be happy to cover during these sessions in the future. And then we have storage classes and dynamic volume provisioning. So all of the mock exams, the ultimate mock exam series, have been updated with the latest questions. So we have about 5 mock exams that are very similar to the actual exam. These are 2-hour long mock exams, and each of them come with a very similar exam structure to what the actual exam is. So do check that out. This is a separate one from the usual Kubernetes courses. We have the Kubestronaut leaderboard available at leaderboard.kodekloud.com. So do check that out. And we have the next cohort that's starting in April. So we'll share a link in the comments, and do register to join the waiting list. So what happens if you join the cohort? You get access to a private community with a lot of others who are on the same journey as you. So this is where we celebrate our achievements. This is where we do the progress check-ins. This is where we discuss and help each other out. So do join that. And it's this may be a good time to book your exams. As I've been saying, this is a good hack to kind of commit yourself to it. So by the exam, book it for a few weeks from now. If you're on the CKA path, I would highly recommend booking it for the end, by the end of the month, or for a date sometime in April, and that will kind of force you to go through and complete the learning and go through the exams. All right. Any questions that I can take right now? Happy to. Sorry, we ran a bit short of time. Should have moved a little bit more faster, but this is the first time we are doing a training session live. So I guess that's for me to take away. And we can plan to go through this a little bit more faster in the future sessions. So if there are any areas that you would like us to discuss in these sessions in the future, feel free to let me know. I would also love to do these together if you're interested, so we could pick a mock exam and go through and do these together during these sessions. And maybe you could, you could answer the questions and win some prizes. So maybe that's something we can do in the future. So if those are things you're interested in, let us know in the comments below. But yeah, thank you so much for your time, everyone. I do not see any additional questions. So the mock exams have been updated. Yes, all the mock exams and all the practice exams, the content on our CKA courses have been updated to match the latest changes in the exam. So yeah, Pedro Meta says, want to start DevOps. Appreciate the knowledge sharing. Happy to help Pedro. Yeah. Kwam had a question about the PSI browser. So I recently took the exam, and yeah, I mean, it's the PSI browser is a kind of a custom browser that you install on your system, right? And what it does is it's a custom piece of software. So you install it, and when you power it up, it blocks out everything, the rest of your system, and it only gives you access to that browser through which you can access certain materials. So it kind of secures your system for the exam. It can be a bit tricky. But there are ways that you can download and set it up in advance and make sure you get familiar with it. And there are some mock exams as in some simple, test exams that you can take with it to get yourself familiar with that PSI environment. So I would highly recommend you to do that. And I think you can do that anytime. I think if you go to the PSI, the CKA PSI requirements page, you'll be able to download that and play around with it. So install it on your system and make sure the prerequisites are met. It's going to ask you to kill a lot of applications that are running in your system. So you want to make sure you you do that. So these can take a little bit of time, and I would highly recommend doing it in advance so that you're not kind of struggling in the last minute. So a question from Saravanan. I'm already in the current cohort. Should I join the second cohort waitlist again? You don't have to. So if you're in the current cohort, just continue with that. Just make sure you catch up with everyone else, by just completing your learning journey and getting your certifications to match the rest of the cohort. But yeah, we also have a buffer time towards the end of the year, so feel free to continue with the current cohort. So Anand Kumar has a question. Anything related to Gen AI space? So we have a lot of courseworks in the background that we're doing that would help in the AI space. So we've recently released a bunch of courses, and we have a lot more that are going to come out very soon and the rest of the year. So just check out the courses listed on our platform. There should be an AI learning path. So definitely check that out. So OpenTelemetry, we have a course that is going to come out that's going to be targeting the certification, and that's going to come out soon. So yeah, this is definitely something in the works. All right, so I think that's about it. I don't see any other questions. I'm sorry if I may have missed out any. Well, thank you so much for being here with us. Really appreciate your time. And until next time, goodbye, and I'll see you all in about exactly 2 weeks from now. All right, bye-bye.